we'll do this. And we'll do start here. Were there any questions from last week that we can go over, or do you want me to just get into this?
No, if people have questions, by all means.
What was it last week? I kind of forgot to come.
I talked about black holes and water on Mars and interstellar visitors. Interplanetary visitors.
Right. What was the name of that big comet that came ripping through? What was the Hawaiian name?
Oh, Oumuamua.
Oumuamua. Yeah.
Yeah. It's actually probably an asteroid.
Oh yeah, asteroid. Yeah.
Or yeah, or a planetary shard if a planet broke up. Okay, well, if any more questions come up, just let me know.
Hey, gang, while Colleen's talking, if we could put ourselves on mute and chime in. Do you want us to just chime in, Colleen, or there is an app where you can put up a hand?
No, just talk away. That's fine.
Okay, cool.
So here are two asteroids in our asteroid belt that right now have sample return missions going to them, Bennu and Ryugu. Here's little Bennu. Can everybody see the screen? That should be my first question.
Yeah, I can see it.
Good. So
Yes,
here we have Bennu. It's 500 kilometers across, and Ryugu, which is a kilometer across. So Bennu is being visited by a probe called OSIRIS-REx. This is a NASA mission. It arrived December 3rd, 2018. It did a touchdown. Well, it will be doing a touchdown in August of this year. So a touchdown and gathering some of the stuff that's on it. It'll depart next March, and then it'll take about 2.5 years to get back to Earth and send off its little sample drop. Ryugu is being visited by the Hayabusa 2 mission, which is a Japanese Space Center mission. It arrived also in 2018. It did a couple touchdowns. It's done an impactor, so it threw something at the asteroid and analyzed what came up. It'll depart, or it departed in November of last year, and by the end of this year, it should have its sample drop. Now, what's important about studying these kind of objects, well, not only are they made up of material that was in the original cloud of the nebula that formed our sun and solar system, but we really need to know what these things are exactly made of, because we are looking out into space, looking for asteroids that may impact Earth, and we will get one eventually. And if we want to try to deflect these type of objects, we need to know their exact composition, which will tell us how to move it. If we had one of these things headed right to us, you can see they're kind of just rubble piles. If it was headed right to us and we sent up, everybody wants to send up a nuclear bomb to explode them, it would probably just go right through it and just scatter into hundreds or thousands of particles. So instead of having one object coming to hit the Earth, we now have thousands of objects hitting the Earth. It could be a much worse thing. Some asteroids are made up of just iron. They're cores of planetesimals that have differentiated into an iron core, and then the outer rubble was stripped away. We need to know, because those things, their density is so much higher, we need to know about them much further in advance. And also, we don't really know a strategy to deflect those yet. Some are being tried out, but it's a multi-year thing to get to one of these things and try a deflection mechanism.
Would it not be less dangerous if it was in thousands of pieces because they would all just burn up in the atmosphere? Or
No, they wouldn't.
asteroids you're talking about, would they just be too big, the pieces?
Yeah, the pieces, there'd be lots that would burn up, but there would be several. Like this big boulder down here. Remember, this is 1 kilometer across, so this is a large mountain-sized boulder. And it obviously made up of something different. That probably wouldn't just disintegrate; it would come right through. So you're going to have worldwide spread of these, projectiles coming through at great speed, so they can cause great damage. I've also made up a list I'll send about some videos about these things. This Hayabusa 2, it also dropped a couple drones, which were really interesting, and it shows how these little drones moved, and it shows some pictures right from the asteroid surface. So I'll send that along. The next thing for this year is the Mars 2020, which is a rover and drone for the very first time. Again, going to Mars. Here's what the rover will look like. It's almost an identical copy to Curiosity, which is up there now. Its name is Perseverance, but much more advanced in its sampling and cameras and things like that. So it will launch sometime between July and August and take about 6.5 months to get there to Mars. It's going to land hopefully at this crater right here, which is Jezero Crater. It's about 50 kilometers across. So imagine sending something out on a 6.5-month journey and be able to pinpoint where it lands to within 50 kilometers. That's quite the mathematical computations that had to be made. And this crater was selected because it contains features that are thought to have been shaped by liquid water in Mars's ancient past. There is a fan-shaped delta deposit in there, which is very rich in clays. And astrobiologists think that clays are very important in the evolution of life, in particular the early forming of long-chain molecules. Clay is sticky enough to grab onto molecules and hold them close enough together so that chemistry can happen and they can join up, but it's not too sticky that then these longer chain molecules cannot then get out into the solution, the water, and do other chemistry with things there and start making life. It's probably how life started on Earth, or at least advanced on Earth, with these clays making long-term or long-chain molecules. So its mission is to land in the crater. Its primary mission is to go to a certain site, collect some samples, go to another site, collect some samples, and then leave the samples all there. If it's still going well, it has a second extended missions to go to different places, as you can see the dotted lines, also collecting samples, also bringing them back to this original site, and then a mission in the future will go there, grab the samples, and send them back to Earth. We talked a little bit about Europa Clipper. I think I mentioned it at some point.
Well, Colleen, for them, so I guess looking at samples there, is it all kind of scheduled out? Like there's like a real long-term plan for how this is all going to happen and get back? So when do they hope to bring back?
Yeah, absolutely. This mission wouldn't be going ahead if there wasn't a collection mission down the road. That's just going to depend on money, probably. So, I mean, this Perseverance is going to do a lot of its own analysis of rocks. I think it has drills and a chemistry set on it too. But one of its main things is to collect these diverse samples and hopefully get them back to Earth, because we have just so much, the labs here just so much than anything we can send. So the Europa Clipper, it's about 3,100 kilometers across. This is the moon of Europa, one of the moons of Jupiter. I think we mentioned that it has a liquid ocean in it. And so hopefully we can get there and find out if there's any biology going on there. It is set to launch in 2024. However, I think the newest census is probably late 2020s, which probably means early 2030s, unfortunately. It'll do a series of flybys looking for signs of life in its ocean. And so how can Europa, that's, 500 million kilometers away at least from the sun, how can it have a liquid ocean? And it's the tidal flexing. It orbits Jupiter in an elliptical orbit. Most orbits are elliptical. And as it's going around Jupiter and the other moons like Callisto and Ganymede, which are much larger, they pull on this Europa, stretching it and compressing it. And anytime you do any stretching and compressing of anything, you get heat. If you have some Play-Doh or silly putty at home, just kind of stretch and press and you'll find out that it does get quite warm. How much water is in Europa? Well, compared to Earth has about 1.5 billion cubic kilometers. Europa has closer to 3 billion cubic kilometers, so over twice as much water on Europa than there is on Earth. Titan, the moon around Saturn, even has more than that.
So lots of does it have like tectonic, like plates, or
no? Let's go back to that one. You can see it's got a solid core, mantle, then this possibly 100-kilometer deep ocean, and then covered in ice. Mm-hmm. You can see some of the ice here. There are some places, one place in particular, I think it's in the south, where this ice is kind of all cracked up, and there might have been an upwelling of warmer water at one point, but there is no plate tectonics per se. So it's just ice floating on liquid ocean. Oh. Joined.
Cool.
Okay.
There was a really good movie about Europa that came out a few years ago.
What was it? Do you remember the name?
It was called Europa.
Oh, okay.
Yeah, and it's and they're going to the ocean, and they discover in the ocean, and they drill down, and what they discover down there isn't quite what we wanted to.
Yeah, well,
and really it got pretty good reviews as far as being scientifically accurate.
Oh, good, except for the monsters.
Except for the monsters, yeah.
Yeah, well, that's okay. We don't know what is down there, so yeah, we never know. So, I wanted to show you just the drone here that's going to Mars. This is just a sample just to see if we can fly in Martian atmosphere. Mars's atmosphere is about 1% Earth, so there's not a lot of stuff for those rotors to go against, to push down on. So this is an extremely light machine with a couple rotors, just a test field just to see if that can actually happen. But the one that's going to Titan, hopefully launching in 2026, is called the Dragonfly mission, and I've got a great video that I can show you after we go through this, and I will send out the link for that also. It's like a large drone with 8 different rotors, hopefully, so launching in 2026, arriving in 2034, so an 8-year trip to get to Saturn. This Titan is the large moon of Saturn. Saturn, or Titan's atmosphere, is actually 4 times denser than Earth's. So, and being a very small body, has a very low gravity. So this little guy with his rotors is really going to be able to fly through Titan's atmosphere quite efficiently. And his main goal is to look for prebiotic chemical processes that are common on Titan and Earth. It will be able to explore several diverse environments, looking at some of the organic dunes. So on Earth, we have sand dunes. On Titan, the sand is kind of replaced with organic molecules, so carbon-containing molecules that then form, because of the winds, form sand dunes. And it's also going to go to an impact crater where liquid water and organic compounds were thought to exist for several tens of thousands of years. So possibly seeing some of this complex chemistry starting to occur that might lead to life. The problem with life on Titan is that it's minus 179 degrees. So all the water on Titan, on the surface of Titan, is equivalent to our granite. So it's frozen solid. It has a hydrological cycle, but it's made out of methane. So it has clouds of methane that kind of rain down, form lakes and rivers and erosion and things like that, and then evaporates up again to form the clouds. And methane is not an extremely good solvent for organic molecules. It is an organic itself, but it's at that temperature to have liquid methane, chemical processes are not going to happen very quickly. Chemistry increases as temperature increases, but at minus 179, not a lot of things are going to happen there. There may be some complex molecules formed, but there's certainly no easy way to get life out of that from that kind of temperatures. The Bepi Columbo mission is the European Space Agency's first mission to Mercury. This will be the third mission. The first mission was, shoot, I've forgotten the name. It starts with an M. There was a flyby mission quite a long time ago. Then the Messenger missions orbited Mercury for a while. Those were both NASA missions. This is the European Space mission. It was launched in October of 2018, and it'll take 7 years to get to Mercury. Mercury is actually harder to get to than, say, Jupiter or Saturn, because you're going deep within the gravitational well of the sun. So you want to speed up and head right into the sun. So it takes a lot longer to get there, and it takes a lot of gravity assists, which is flying by another planet to either slow up, go faster, or change direction. Just last week, it flew by Earth to get a directional change and a little boost in, actually it slowed down a little bit the way it hit Earth. On the left, you can see as it's approaching Earth, and then on April 10th, as it went right by Earth at about a distance of a little over 12,000 kilometers. This was its first of 9 flybys that it's going to go through. So it does Earth once, it does a couple on going by Venus, and then 6 flybys by Mercury itself to be able to get the right speed, with, slowing down and to be caught by Mercury in an orbit. So launched 2018, will arrive in late 2025. So a 7-year journey. And remember, we learned last week that Mercury is the closest planet to Earth most of the time, but it still takes 7 years to be able to adjust these flybys to get captured by Mercury. And it's hopefully a 1-year mission with another year extension. When it arrives there, again, Mercury being so close to the sun, it's got to have some very special qualities. It's about 350 degrees Celsius on Mercury. So it's got to be able to not get burnt up by the sun too much. So we all know Elon Musk, and he's awesome. He does a lot of great things. This, unfortunately, is not one of the great things he has done. He is putting a constellation of up to 15,000 satellites to cover the whole world, to bring cheap internet to every part of the world. Some places are still not internet accessible, and he figures by doing this, he will do it. So that's a great idea, you know. Lots of satellites up there, bringing the internet to everybody. However, for astronomy, when we take long exposures of the night sky, this is the sort of thing we're getting now. So this is would have been a beautiful picture. You can see there's a galaxy here and here. That's probably a galaxy, lots more galaxies. But it was taken at one point where all these Starlinks flew by. He says he's trying to mitigate them. So these aren't lit by anything except by the sun. So it's just the reflection of the sun on the solar panels that we're seeing. So one of the last ones he sent up, they painted the Earth-facing size a dark color to hopefully minimize this. Unfortunately, that just meant it absorbed heat, so its infrared signature was increased, and it still bounces radio waves off. So all of astronomy, right from radio waves into the infrared, is kind of being destroyed. And that's just one constellation. There are others that are planning to go up by different companies. So there could be 40,000 of these type of satellites in Earth orbit.
Just a question, Colleen.
Sure.
It seems like we have this huge untapped kind of resource and area up there. Who determines what can be done? I mean, you start looking at private enterprise like Elon Musk and what he's trying to do. Although it might be for good, but it obviously could be opening up Pandora's box.
Yeah, he did get permission, but from some agency. I don't know if it was the International Astronomical Union or what, to do this, but I don't think they realized exactly what he was doing. And there is a treaty right now in place that says the universe belongs to everybody. So nobody can claim the moon, nobody can claim an asteroid. I don't know if it covers this type of thing, but of course, a couple of weeks ago, Trump signed a thing saying that Americans can mine asteroids in the moon. So certainly there are lots of organizations, including the RASC, that are looking at this and trying to figure it out and trying to help them make decisions so we don't get this kind of thing. But
yeah, I would think with all the instruments and satellites that are used for science and predicting weather and all these type of things, that adding up so much more debris, space junk, if you will, like that are potentially to be, things floating around our atmosphere, that it would be counterintuitive.
Yeah, well, these satellites will be at about 600 kilometer orbits. The ones that NASA has for looking down back at Earth for oceanographic and planetary observations, I believe, are about 12,000 kilometers up. So there's a big area where these go. The International Space Station is about 400 kilometers up. So there are different levels, but the space junk that is up there right now is amazing. And some people are trying to figure out how to get it down. A lot of it will just fall down by itself, and with the Earth being over 70% water covered, most of it's going to fall in the water. Whatever doesn't fall in the water will probably fall in Siberia because they're the next biggest area. But NORAD, I believe it's NORAD, tracks, I think it's 100,000 pieces of junk up there that are 10 centimeters or larger, because the space station has had to actually adjust its orbit not to hit into some of these things. China did a very bad thing several months ago. It actually sent a rocket up to explode one of the satellites up there. It was target practice. So that made one object into probably tens of thousands of objects that now have to be tracked. And there are some other that have happened. Nobody kind of knows the rules up there, who has to veer off. I believe it was a year or so ago, 2 of the satellites, not these ones, some other ones actually hit because they were waiting for the other person to move.
Maybe we could make space junk a topic. That would be a.
Yeah, that would be great. Space junk. Got it.
I was reading before about them actually trying to use static electricity to build up a bit of a charge, and because you're out in space, you don't have to build up too much of a charge to be able to you know, attract something to you or repel it, right?
Yeah. And there's also talk that any new satellites that go up in the future need to have a plan that once that satellite no longer works, it will be boosted to a much higher orbit, so that it won't interfere with all the other ones. But yeah, space junk, it is amazing. And this has gotten, so he's only got about 300 satellites up there right now. There is enough for Space Weather to have a whole gallery of these kind of pictures. One of the newest ones was taken from a fellow in the Czech Republic, and he actually saw Starlink going in 2 different directions. So it's becoming quite a problem. He was looking for this little comet down here, taking a picture, and he got all these ruined areas of the sky. So. And my last topic for today is the Crew Dragon. Now this is an Elon Musk amazing thing that he's been doing, his SpaceX. The Crew Dragon is going to be launched May 27th with 2 astronauts to head to the International Space Station. It will be the first non-Russian launch of people.
Is this the new Soyuz?
Yeah, since the last shuttles were used. I forget how long. It's been a long time since Americans have been, or anybody but the Russians have been launching. And it's just an amazing accomplishment that Elon has done. He's very innovative. He redesigns everything. Let's see what I've got here. So here's a look at the inside of this capsule. Now, so far, the Mercury missions had held 1 astronaut, the Gemini 2, Apollo 3, and very cramped. The space shuttle could hold 5 or 6. The Russian Soyuz can hold 3. This spacecraft can hold up to 7 astronauts. NASA will generally use just 4 at a time, but it can hold up to 7 in just a beautifully designed ship. And like I said, he just redesigned everything, including the spacesuits. And one of the first times we saw the spacesuit was Starman here. He launched his Tesla with a little Starman in it. But here's the actual spacesuit, so completely different than what is used up to now. And here are the NASA astronauts. This is Bob Behnken on the left and Doug Hurley on the right, and they will be going up May 27th. Starting May 1st on NASA's website, they're going to hold massive amounts of briefings to get everybody up and running on this thing and telling it what it's all about. There are two other companies building these kind of spacecraft, the Boeing Starliner and the NASA Orion, and both are having massive problems and won't be ready. Well, NASA keeps saying its Orion is going to be heading back to the moon in 4 years, and I think I expressed my non-optimistic opinion on that. Yeah, they're having both of them are having serious problems. So this one looks like the one that will be the go-to for right now.
So this Crew Dragon, so it's going up to the International Space Station.
Yes.
Probably only need one, one shuttle going back and forth between the International Space Station.
Yeah.
Why are the other people trying to make something to do the same job? Are they thinking for in the future, if there is like a space colony or another type of like a space station, that they would be the ones to go back and forth to there?
Well, it's diversifying. So if one group is having a problem, maybe the other groups won't. And that's NASA's way of doing things. It doesn't usually build things itself. It farms out everything. So several years ago, it put out the call. If you're interested in building, and being any part of this, to show them their designs. SpaceX and Boeing came in with the best designs, and some of the NASA people that are hoping to build the Orion, they came in with the best, so they are being actually funded by NASA to build these things. And SpaceX just does it better than anybody else. And also, we talked about the Gateway and going back to the Artemis project, going back to the moon. So it's good to have multiple vehicles to get to wherever you're going. SpaceX is planning on heading to Mars after probably a few years of what it learns from these newest launches. Any other questions? That's all I've got really for today, except the videos if you'd like to see. Okay, let's escape out of here.
Would you have a video? What was the video of, Colleen?
Yeah, I'll show. It's just here.
Oh, Jace, no worries that your power went out. That happens.
Okay, so back to Zoom.
God, those spacesuits look so different. Like they look like Star Trek.
Colleen, what's the reason that NASA contracts out some of its projects? Is it more cost efficient, or do they just have so many things on the go that they have to?
NASA has always farmed out. I can't seem to share my. Yeah, NASA basically doesn't build anything. It farms everything out. So even during the Apollo and Mercury missions, all those ones, all those things were built by other companies. So that's one thing when people say, oh, we didn't really go to the moon, it was all a hoax. So you have to have, at the height of the Apollo mission, there was 500,000 people working on the various aspects. And the projects farmed out. So you had different people building the lunar module, different people building the command module, things like that. So the theory about being a hoax. So either these companies knew it was a hoax and were just putting out anything, or very few people knew it was a hoax and they actually had. So these companies actually had to build working things. And if you're building working things, why wouldn't you use it? So yes, we have gone to the moon. I seem to be having a problem sharing my screen on my, let's see if I can I'm always coming back to that. Get rid of that. Oh, okay, screen is shut, window is closed. Nice. Okay. Are we seeing that screen now?
We're on your YouTube.
Yeah, yeah. Okay, so this is Bepi Columbo's journey to Mercury. Just so left launch from Earth. Stayed close, kind of close to Earth. You can see it's a bit different elliptical orbit. So that's 1 year that it took. So we're just doing flybys. Here it goes by the Earth again. That was the one that just happened, which allowed it to change its orbit. Then it goes by Venus to change its orbit again.
And it has to do all of this because of the strong gravitational pull of the sun.
Yes, yes.
That's
So it's slowing down as it goes by each of these planets and changing its direction. Here starts the, was it 6 what times that it has to go by around Mercury. And eventually it'll be in the right orbit and the right speed to actually be able to be caught by Mercury and orbit it. But you can see it takes a long time. Another reason why spacecraft do this, it's very hard to get off the Earth. For every kilogram of stuff you want to get into space, you need 4 kilograms of fuel, which then needs more fuel to boost that fuel. So you want to send up as minimal amount of weight as possible. And so we send it up, we get off the Earth. To minimize the amount of fuel that we have to carry, we then use these flybys for to increase speed, increase or decrease speed. To increase or decrease speed and to change orbit. So we don't have to carry as much fuel to get out there. The one really interesting one is a space mission that went to the sun. And instead of going around the sun at the equator, it wanted to do a polar orbit. And to do that, the spacecraft was launched from Earth and went to Jupiter. And using Jupiter, it managed to get caught in Jupiter's gravitational field and managed to change orbit into a polar orbit that then could get close to the sun. So the Voyagers and the Pioneers all use the outer planets to adjust their speed, direction, because we can't send enough fuel for these kind of things. Here's another one. This is the Dragonfly mission that's going to Titan. So here we see the parachuting down through the dense atmosphere. The little drone can then fly down. So this bottom part here, that's a seasonally filled lake of methane. It'll land when it's in the dry season. It's got a little antenna to send back information to Earth. Check out wherever the sun. And then, like I said, because of its rotors and the dense atmosphere and the much smaller gravity, it's going to be able to go on very long hops, kilometers at a time, going maybe 100, I think it's estimated a total of 200 kilometers. And was there one more? Oops, I gotta turn that off. Turn that off. And here's just a little bit about those robots.
Scientists have been studying asteroids for years. NASA, for example, landed its near
It's not what I wanted to show you.
Earth and Mars, making it all goes according to plan. Well, aren't your typical space
So
robots.
here's two of the
They're
little
slightly
robots.
bigger than the size of a large iPhone, measuring just 7 by 18 centimeters, and they won't be driving around on the asteroid's surface. They'll be hopping. Yeah, you heard that right, hopping. Japan designed the rovers with a spinning cylinder inside that gives it the power to hop about a few meters at a time.
There was another one that. These little guys are interesting, yeah. So again, these are some of the little robots.
Japan hopes to collect and return a sample of Yugu to Earth so that scientists can study it in more detail, looking for traces of water and organic material. If it turns out that asteroids like Yugu contain similar material.
I thought I had a really good spot where they were hopping around, but I guess I didn't. Anyway, okay. That's what I prepared for today. If there are any questions or other things you'd like to see in the future?
Yeah, that's super cool. You look at like those the probes and the different things that they send. You know, there's so many different types and kinds of them, I guess, that are designed to, you know, meet various needs of where they're going or the knowledge at that time, and then, you know, things have been improved upon, right? So, you know, I imagine, you know, the instruments and things that get sent up there now are far more sophisticated and have, you know, more abilities to gather information than ones in the past.
Oh yes, but especially those big rovers that have gone to Mars, both Curiosity and now Perseverance. The amount of equipment and things that are testing abilities and are on them are just phenomenal. And again, they have to take into account the gravity of whatever object they're going on, the atmosphere, if there is one, and things like that to maximize the usefulness of these probes.
Mm-hmm.
I did mention that it's hard to get off Earth. If Earth was only 15% greater mass, there's no way we could get off Earth using rockets. We are almost at the limit of mass. So if we look out into the universe and we see planets around other stars and we see how massive they are, and if they're much more massive than the Earth, we know that nothing is coming off of them. There isn't a fuel able to get off anything that large. And will not, even in the future. The universe is made of all the same stuff. Only certain stuff can be used as fuel. So large planets are not going to be space travelers.
We need a new field in physics.
Yeah, yeah. Once we get off planets, it's awesome. We've got lots of different things, ion thrusters, hydrogen peroxide, lots of different things. But to get off the planet is the first thing.
Mm-hmm.
I have a few questions.
Awesome.
One, for the thing that's headed to Mercury, are they using tungsten for that? Because as far as I know, that's the most temperature resistant material.
I do not know what they've made it out. I know they have some sort of sun shields on it that are wrapped, but I could not tell you what it's made out of. It's a good question.
Okay, and second thing about what you just said, what if let's say that there is life on a much bigger planet than us?
Yeah.
And they have a better fuel source than we do.
That's the thing. There is no fuel source that
we know of.
So in the 1930s, when rocket science came of its own, every conceivable, they were trying to find the best fuel. and every conceivable combination. And it's continued, this study has continued. There's just nothing available in the universe that can get space travelers off a heavy planet. Sorry.
Even if they have materials that we don't know of, like
We know
new
all,
elements.
when we look out into the universe, all the elements everywhere are the same. There's nothing exotic about anything. If it's out there, we have it here. So
I guess it'd be a new understanding of how things work. It would have to be, or
again, chemical propulsion systems are the only thing that can be used to get off a planet. Once you're into deep, off the planet away from the gravity, there are a multitude of different things you can use. You can use flybys, like we saw. You can use ion thrusters. So that's just heating up a plasma and throwing out an ion one at a time, gradually building up your speed. And actually, I believe Bepi Columbo was using some ion thrusters. But to actually get off the planet, you need chemical explosions and
combustion.
Combustion, that's the word. Yes, yes. And it's just, there's nothing out in space that we don't know of chemically.
What about a space elevator?
That was really looking promising, and there were lots of projects and contests to see if anybody could come up with a space elevator. We do not have even using carbon nanotubes, we don't have the technology as of yet to do it. It's an awesome idea. Just park something, several thousand kilometers above the Earth and have carbon tubes running up it that you just hop on and continually move up. That thing's got to be geostationary, so it's got to go with the Earth. Then you're also looking at time travel and things like that, because you have something farther from a gravitational well that is moving faster than the Earth. So there's lots of challenges, but I personally love the idea of a space elevator. And if you've read any of the Red Mars, Blue Mars, Green Mars series, they use space elevators in that. There hasn't been anything new in the last couple of years on space elevators. It's just not currently viable.
Does anyone have any other questions about the presentation from today, or if you can think of anything that you're really curious about that maybe we could look at sometime in the future as well? Newman, anything?
Not immediately, no.
And how about you, whoever you are, Hamilton? Any curiosities? Anything that you're wondering about?
Nope, everything was explained really well. I don't really have any questions.
Well, see, I didn't do a good job then, because I'm hoping to stimulate your mind enough that you will have lots of questions and then go out and find out things for yourself.
I guess a question that's for me, just thinking about the logistics of it and just the politics and all the different companies and things that are involved in it, would just be like the sources of money. Like where the sources of money come from, and are people giving money for the sake of exploration and science, or what's the end game? What's the motivation for all of these different people to be involved in it? Right, because in the end, we're kind of in a capitalist society, and people are probably looking out for themselves. So what's
definitely SpaceX is planning on making a bunch of money, lowering the cost of space exploration by reusable rockets and things like that. Any large company, I'm sure, is looking out for monetary values. What they can make out of it, but I think at the base of every human mind is this question of what is out there and are we alone? And I think all of that combines into it. I mean, you're just not going to build rockets just to get money. You're going to have a basic query of what is out there.
Mm-hmm.
Are we doing this next week?
Yeah, that sounds great. If you're up for it, we can, as long as you're willing to keep rocking, we like this.
So far, so good. Okay, so I'll cover space junk next week, and what life might look like on different planets, seeing what kind of physical characteristics are adaptable to each type of planet.
That sounds super interesting. And anything else? This is our biggest showing yet. This is our biggest class. So we're building here. We're getting,
how many do we have online right now?
we got 9 or 10.
Awesome. Anything else you'd like me to cover?
Can anyone think of anything? If you can think of something when we're offline, you can send me a message or send me a text,
Absolutely.
and I can pass that message on to Colleen.
Black holes, maybe?
Yeah, everyone likes black holes.
That's what I thought. A little more in depth. We've scratched the surface of the event horizon, but a little more depth in what would happen to you if you fell into one.
And anything you're passionate about. I mean, I guess all of space. I guess you're pretty into it.
Yeah, everything from string theory to cosmology. So.
I'd say if you went into a black hole, you'd most likely be crushed.
Well, keep that thought.
A massive ball of gravity that sucks in light.
Yeah, just keep that thought.
String theory might be interesting to look at sometime.
Yeah.
It's pretty theoretical and tough to wrap your head around, but.
Well, it's actually a misnomer. You cannot call string theory a theory because it doesn't suggest any type of tests that could be done to either confirm it or.
So it's a misuse of the word theory in relationship to science?
Theory. Yes, yeah. Even though that's what scientists have called it, it really cannot be called a theory at this moment.
See, and that's silly. Do you think that, like, because in the social sciences, theory means something different as well? So then, yeah.
Yeah, theory should only be used in a scientific explanation of things. Yeah.
Yeah, I agree.
Because most people think, oh, it's just a theory. No, it's just a guess. But
that's not what it means in
explain
science.
the word theory.
Right. Cool. Well, any other questions or comments before we end for the day? All right, gang. So keep track on the Google Calendar. We're going to keep the space space at this time, and in a couple weeks, I'll find a time on the calendar if people have been working on projects or putting together projects. It'd be an opportunity to present. In any way that you want, videos, or you could do it on here like this, or however you want to present. If you want to try working with a partner, it might be difficult, but it could also be super cool to try to do that during, this time and try to communicate with each other online. I don't know, it's your call. I do know that there was about 2 or 3 of you that were interested in doing a presentation, and anything that you do right now, also I can be looking at for assessment and credits and things like that. Any questions? All right, gang. Well, that was super awesome. Thank you very much, Colleen. My brain is full.
That's my plan. Well, thank you again for inviting me into this group. It's been wonderful. And we'll see you next week.
Thank you, guys. Bye-bye.
Bye now.
Bye.
Bye.
See you next week.
Thank you.